Hi, my name is Darvin.
And I'm Andros.
Today we're talking about the Carnot cycle, which is the most efficient heat pump cycle. On a TS diagram, which is a temperature entropy diagram, we have a saturation curve. The Carnot cycle works underneath the curve. From points 1 to 2, we have work in, which is done by a compressor. From 2 to 3, we have Q out, and this is done by a condenser. Let me just fix that. From 3 to 4, we have work out. And from 4 to 1, we have Q in, which is done by the evaporator. The upper and lower limits of the curve, we have T1 and T2, in which T2 equals T3 and T1 equals T4. From 1 to 2, we have S1, that's entropy, equals S2, and S3 is equal to S4. This is the most efficient theoretical cycle in a heat pump that we have. Good. What do you think? Okay, so the other thing that we want to talk about is the coefficient of performance. If this is Q high and this is Q low, then for the coefficient of performance for refrigeration, we have Q low over Q high minus Q low, which is also equal to T1 over T2 minus T1. And for the coefficient of performance for a heat pump, we have Q high over Q high minus Q low, which is also equal to T2 over T2 minus T1. Thank you.
Go. A heat pump is a device which applies external work to extract an amount of heat from a cold reservoir and delivers heat to a hot reservoir. A heat pump is subject to the same limitations from the second law of thermodynamics as any other heat engine, and therefore a maximum efficiency can be calculated from the Carnot cycle, like we have here and has been demonstrated. Heat pumps are usually characterized by the coefficient of performance for refrigeration and for the heat pump, which is a number of units of energy delivered to the hot reservoir per unit work input. Air conditioners and heat pumps are heat engines like a refrigerator. They make good use of the high quality and flexibility of electric energy, and in that they can use 1 unit of electricity to transfer more than 1 unit of energy from a cold area to a hot area. Thank you.
Okay, so earlier today we were talking about the Carnot cycle and refrigeration and heat pump. So what we have here is a heat pump. Water comes in, goes through the cycle. They have it has a fan here for air conditioning the room. And we'll look inside, see what's in.
Okay, so now we're ready to look inside the heat pump. Now, as we see here, this is the compressor, this is the condenser, this is where the work out goes, and then that is the evaporator. Now, how this works is, sorry, give me a sec. So, water goes in, hits the evaporator, okay, and then water comes out here and feeds the compressor. The compressor then feeds the condenser, and then the condenser, you see right down here, if you could look, all the condensate comes in this little tray right here, and then this is the condensate drain right around the corner where it says drain. That's the condensate drain. So what happens is if it's on a heating cycle, water comes in and then it's heated and the workout is hot air. And then when it's a cooling cycle, the workout is cold air. And that is it. Thank you.
Okay, so that was our simple overview of a heat pump refrigerator. Thank you.